We dream of discovering distant worlds, overflowing with rich vegetation and life, just like here on Earth. The James Webb Space Telescope has now discovered a real atmosphere on a distant super-Earth for the first time. We could therefore be well on the way to finally exploring a world similar to our own in the depths of space. But 55 Cancri e presents researchers with a puzzle. The exoworld, which is only 41 light-years away from Earth, sometimes appears as a super-Earth and sometimes as a hellish furnace. But which is true? The James Webb Telescope has made some astonishing discoveries in the search for answers to these questions. Researchers are using NASA's new JWST to finally take a close look at the Earth-like planet 55 Cancri e with the help of this groundbreaking technology. This exoplanet is a direct neighbor of Earth on a cosmic scale. This world has astonished researchers time and again since its discovery in 2011. At first, the planet appeared to be a hot but rocky world that may have an atmosphere, but then scientists discovered shocking new data about this planet. Using Webb's unique methods of analysis, researchers wanted to finally unravel the mystery surrounding this mysterious planet, and they succeeded. The results are astounding, and the study leader, Renyu Hugh, from NASA's Jet Propulsion Laboratory was thrilled. With the James Webb Telescope, we are now entering a completely new dimension of science. For the first time, we know exactly what is going on around the exoplanets, and we can even get our first impressions of the planet's surface. 55 Cancri e, super hot or super Earth? Can you imagine a boiling hot super Earth? Probably not, and that's absolutely right, because normally only planets that offer even better living conditions than our home are called super-Earths. As a rule, such planets are a little larger, a little denser, a little warmer, and their stars have a longer life expectancy than our Sun. The first 2 points applied to 55 Cancri e for a long time. We knew the size of the planet, its orbit, and its approximate density. However, we had no concrete data on an atmosphere, and even the temperatures were only estimates. Never before in the history of astronomy have we been able to study planets outside our solar system with such precision and detail. Webb spectrometers can not only detect water in a planet's environment, but also gases such as methane, carbon dioxide, and other volatile compounds. The more similar the analysis data of the planet's environment is to the values of our Earth, the more certain we are that we have found a real super-Earth. 55 Cancri e is one of 5 known Earth-like planets orbiting the Sun-like star 55 Cancri. With a diameter almost twice that of Earth and a higher density, the planet was previously classified as a super-Earth. Earlier studies of 55 Cancri e yielded strangely contradictory information. For example, studies by the Spitzer Space Telescope showed that the planet orbits its star so closely that its surface is probably less rocky and more molten. Furthermore, the planet's orbit is probably bound. With a day side and a night side, the supposed super-Earth could be a scorching hot place that neither harbors an atmosphere nor can support life. Researchers have repeatedly taken on this strange world, and specialists from the University of New Mexico have now studied 55 Cancri e intensively for more than 10 years. The scientists described it as downright frustrating that none of the observations had so far yielded clear results. The new telescope should finally bring light into the darkness and reveal the secrets of this planet. 55 Cancri e has 2 atmospheres. Is it possible for a planet to have 2 atmospheres? Yes, 55 Cancri e once had an atmosphere, which was then blown away by its star. It's almost unbelievable, because this mutable planet simply grew a new atmosphere. The spectrometer analysis surprised scientists. They had never had such detailed and extensive data on this planet before. Using the latest data, the researchers were able to accurately reconstruct the history of 55 Cancri e's atmosphere, and it is truly strange. Due to its extreme proximity to its star, surface temperatures of around 2400 degrees Celsius have literally burned away the protective shell. But this exoplanet performed a miracle and simply replaced the original atmosphere of hydrogen and helium with a new one. This secondary atmosphere was formed in a fantastic way by outgassing from the rocky interior of the planet. It was probably the high temperature at 55 Cancri E that caused a new atmosphere to form. However, the new atmosphere is quite different and consists mainly of carbon dioxide and carbon monoxide. Webb's most accurate spectrometer analysis. Do you wonder how the JWST can detect such details? The light that reaches us from 55 Cancri E is so small that Webb could never take a direct image of this planet. However, the telescope can measure minute changes in the system's light as the planet orbits the star. The data from the MIRI instrument show the 55 Cancri system's brightness decreasing as the rocky planet 55 Cancri E moves behind its star. Scientists refer to this phenomenon as a secondary eclipse, and the images of the analysis diagram show a secondary eclipse light curve. During a secondary eclipse, the light reflected or emitted by the planet is obscured so that only the light from the star is measured. By comparing the brightness before and during the eclipse, the amount of light coming from the planet can be isolated and analyzed. The data show a clear drop in brightness caused by the planet's emissions. Analysis of these emissions revealed that the temperature on the day side of the planet is about 1,540 degrees Celsius, which is much lower than expected and indicates a volatile, rich atmosphere that distributes energy from the day side to the night side. Absolutely crazy. Life on 55 Cancri E? It sounds crazy, but previous data from NASA's now defunct Spitzer Space Telescope repeatedly indicated the presence of an atmosphere with signs of oxygen, nitrogen, and carbon dioxide. These could be biomarkers and evidence of life. But how can it be that a planet with such extreme surface temperatures shows traces of biomarkers in its atmosphere? Planetary researcher Hugh explained in his article in the journal Nature that 55 Cancri E even showed signatures of metallic substances and elements such as silicon, iron, aluminum, and calcium. However, the temperatures are so high that scientists suspect that the source of these traces could be a thin veil of vaporized rock. This raises the exciting question of whether this planet was once cooler and knew biological processes. We know from our own solar system that planets have swapped positions within the system over the course of millions of years. It's possible that the rocky world 55 Cancri E was once in a habitable zone and only later moved into an orbit that brought it closer to its star and the devastating temperatures. Our Mercury is also being pushed further and further towards the Sun by Jupiter, and some researchers assume that Mercury was once in an orbit further away from the Sun. Then it could be that there was once life on 55 Cancri E. The exoplanet appears more and more like a world of stark contrasts and a world that has undergone violent changes. This is shown not only by the bound orbit, but above all by the contradictory measurement results from the various telescopes. The first indication of a considerable atmosphere came from temperature measurements based on the thermal emissions of this world. If the exoplanet is really covered by dark, molten rock and a thin veil of vaporized rock, the day side should be about 2,200 degrees hot. Webb's MIRI data, however, showed a temperature of only 1,540 degrees Celsius. This may be due to the fact that the energy is well distributed by thermal processes between the cool night side and the hot day side. Lava flows transfer heat to the night side, where it is circulated and cooled. Nevertheless, simulations showed that this effect alone is not sufficient to explain the much lower temperature. When the research team examined further data from Webb's NIRCam, patterns of a volatile but rich atmosphere were again revealed. This does not fit with a planet made of vaporized rock. The team led by planetary scientist Hugh has come to the conclusion that 55 Cancri E has some special feature that must have something to do with the escape of gases from its interior. Thanks to Webb, research into this exciting planet has come a long way, but is still far from complete. Real traces of life in space? Are you fascinated by such groundbreaking findings as those about 55 Cancri E? Or are you one of those people who would be much more grateful if we could finally prove the existence of real extraterrestrial life in space? Even if we have not yet succeeded in providing definitive proof, the James Webb Space Telescope has brought us closer to this goal than ever before. In addition to an unprecedented range and sharpness, the JWST offers us the opportunity to take a close look at exoplanets for the first time. Although some of these planets are huge, they are tiny objects compared to the dimensions of the entire universe. For a long time, tracking them down was like looking for a needle in an almost infinite haystack. We now know of more than 5,000 exoplanets. That's a lot for our science, but measured against the actual number of planets, it's not even a handful. The exact number of Earth-like planets is constantly changing. So far, we have a few dozen candidates that have what it takes to be Earth 2. Webb is now to clarify which planets are really Earth-like and which are not. Proxima Centauri b has often been named as the most Earth-like planet. This planet, which is only 4 light-years away, orbits the star closest to us and lies in the habitable zone, where the conditions for liquid water are good. Our hopes of finding life there faded after the star Proxima Centauri directed violent flares at its planet. After this disappointment, attention turned to other important candidates such as Kepler 452b and TRAPPIST-1e. Webb was able to confirm the existence of the Earth-like planets in the TRAPPIST system, but the individual analyses are still lacking. The star TRAPPIST-1 probably has 7 planets around it, 5 of which are similar to our Earth. Kepler 452b is currently the most Earth-like planet ever discovered in space. The James Webb Space Telescope has detected light beyond the Dark Ages, a period of time that began just after the Big Bang and lasted about 1 billion years. During this time, the universe was supposedly filled with dense clouds of neutral hydrogen gas that blocked out all light, making direct observations of early galaxies long considered nearly impossible. But now scientists have found that strange sources of light are coming from these dark ages, and we must seriously wonder if we have misunderstood the universe so far. Using the James Webb Space Telescope, or JWST for short, the mystery of the Dark Ages has now been solved. The telescope's discoveries show that there was indeed light during the supposed Dark Ages. Webb observed Lyman alpha emissions, which are produced by the interaction of ultraviolet light from young, hot stars with surrounding hydrogen gas. Surprisingly, this light reaches us, so it was somehow able to penetrate the dense hydrogen clouds of the Dark Ages. Researchers speculate that this was most likely made possible by the formation of bubbles and channels of ionized hydrogen. The ionized hydrogen came from the first stars and galaxies, which created bubbles and channels, and thus gaps in the neutral hydrogen gas, and it was through these gaps that the Lyman alpha emissions escaped. The first discovery of Lyman alpha emissions from this epoch was some time ago. Even before the launch of the new space telescope, researchers were able to receive and study these faint signals from a largely unexplored period. The Webb telescope is now showing us yet another facet of this discovery, and it has far better capabilities to detect and analyze the Lyman alpha rays. So far, the overall picture suggests that the first galaxies and stars were formed much earlier and on a larger scale than previously thought. Since its launch in 2022, the JWST has shown us a series of galaxies that were already very advanced and bright during the Dark Ages. The very fact that we can see these galaxies shows that there was even more light in the Dark Ages than previously thought, and that the Lyman alpha emissions were not the only waves that penetrated the darkness of space. So far, the discovered galaxies show all signs of an extreme star formation rate, and they are unusually large. The evidence of intense star formation alone paints a very different picture of the early epoch of the universe. If there were more stars in the past, then the universe was also illuminated and permeable to light earlier. Based on the current situation, scientists must also come to terms with the idea that the Dark Ages never existed. One of the most significant discoveries of the JWST are 2 high redshift galaxies that are so old that they existed long before the Dark Ages. The age of these galaxies is so extreme that, strictly speaking, they must have existed even before the Big Bang. This shows that something is wrong with our previous data. These galaxies have an extremely large number of properties that do not match the previous models of the origin of the universe. Another example that is currently giving scientists a headache is the discovery of a supermassive black hole at the center of one of these galaxies, which existed only 400 million years after the Big Bang. Such observations completely challenge the current understanding of the cosmological timescale and our old theories of galaxy formation. The real reason behind Lyman alpha radiation. What is certain is that Lyman alpha galaxies play a crucial role in the study of early galaxy formation and evolution. Now, we just need to find out what exactly these emissions are telling us. Lyman alpha emissions are produced by the transition of electrons in the hydrogen atom and are normally found in the ultraviolet spectrum. From our point of view, however, the emissions are increasingly redshifted because the universe is expanding and the light of the waves changes optically for us as a result. However, this effect gives us the good fortune of being able to better capture and study the emissions. The JWST is virtually predestined to capture waves in the red light spectrum. Lyman alpha emissions, or LAE for short, are like a silent beacon for scientists from the times that we have long considered to be the earliest phases of the universe. They enable astronomers to identify and study processes in galaxies that took place just a few 100 million years after the Big Bang. This should actually be the time period in which the first structures in the universe were formed, and LAEs would therefore be important messengers of this time. However, emissions can also play an important role in changing our view of the universe. This is because we no longer know whether the idea of the Big Bang is really true. All observations are important new indications of a worldview that is different. Scientists wanted to use LAEs to clarify the processes of the reionization epoch. Until now, the idea was as follows. After the Big Bang, the universe went through the so-called Dark Ages, a period in which there was no light because there were no stars or galaxies that could produce it. On top of that, the universe was still a very dense soup where light rays could not have passed through. The point at which the universe became bright and permeable to light is what scientists call reionization. LAEs must have played a key role in this. But what if neither a dark age nor reionization really existed? Then researchers have misinterpreted the LAEs so far. Thanks to the latest discoveries from the Webb telescope, the picture is becoming clearer. Now, by studying LAEs, scientists can better understand what was going on in the galaxies Webb shows us. LAEs provide reliable information about how many new young stars have formed in galaxies and how the intergalactic medium has behaved during this epoch. By studying LAEs intensively with the latest telescopes, scientists will continue to gain more information about star formation rates in early galaxies, and this data will help us piece together the puzzle. Eventually, we will know if these galaxies are really baby galaxies in a young universe, or if these galaxies formed in a completely different way and are much older. The images that the JWST has provided us with so far show astonishingly star-rich and bright galaxies. If we want to understand what happened in these galaxies, we need to use every available source of information. Another high-power telescope, the Vera Rubin Observatory, will soon be launched to give us even more clarity. All we know at the moment is that the strength of the Lyman alpha emission is often an important indicator of the amount of new star formation. The jets are also produced in star-forming regions that are much younger. By measuring and analyzing these emissions, scientists can quantify star formation activity in early galaxies and thus draw conclusions about the processes that led to the formation and evolution of these galaxies. Webb discovers more and more LAE galaxies. What this telescope is accomplishing is truly mind-boggling. The James Webb Space Telescope is looking farther and farther back than any other telescope before it, and it has revealed impressive examples of Lyman alpha emitters that are now so important to research. One of the most notable of these discoveries is the galaxy GN-Z11, originally identified by the Hubble Space Telescope and later confirmed by the JWST. With Hubble's measurement data, researchers still thought it was a mistake because GN-Z11 existed around 400 million years after the Big Bang. This age was already unusual in Hubble's time, but it was thought that perhaps this galaxy was a measurement error or a strange outlier. Now, thanks to James Webb, we know that it's real and that Hubble did not make a mistake. The spectrometers of the JWST show strong Lyman alpha emissions in this galaxy, which again points to intensive star formation in this galaxy. GN-Z11 has thus heralded the revolution in scientific understanding of the rate at which galaxies can form in the earliest phases of the universe. Another important example is MAC-S 0647-JD, a galaxy discovered in an early galaxy cluster. This galaxy is extremely faint and is in a very early phase of the universe. Nevertheless, the JWST observations show that MAC-S 0647-JD has strong Lyman alpha emissions and is thus producing a large number of new stars. This galaxy shows unusual activity for an actually faint and presumably small galaxy. Finally, we have the galaxy EGS 8P7 in this list. It lies around 13.2 billion light-years away and also shows surprisingly strong Lyman alpha emissions. These emissions suggest that EGS 8P7 was able to create bubbles of ionized hydrogen around itself that allowed the LAEs to escape. There is still the question of whether the idea of reionization was correct, because the JWST shows us several galaxies from this theoretical epoch that are much too bright. So far, however, we have not found any signs of a darkness that has obscured everything. The strangest black hole in a galaxy. Let's take another closer look at the galaxy GN-Z11, which existed about 400 million years after the Big Bang. A supermassive black hole has been identified at its center. This discovery once again raises many questions about the formation of such massive objects in the earliest epochs of the universe. The presence of such a large black hole at such an early stage contradicts previous theories which assume that supermassive black holes are formed by the collapse of massive stars or by the merging of smaller black holes. These processes take billions of years, and so this black hole is also scientifically impossible. What does this discovery now tell us about the old theories and their veracity? We have to consider that alternative mechanisms for the rapid formation and growth of black holes also exist. One hypothesis is that these black holes gained mass rapidly through direct accretion of gas in material-rich regions of the early universe. Other hypotheses suggest that previously unknown forms of exotic matter or energy could be responsible for the rapid growth of the universe. It's astonishing that so few scientists are currently able to officially dispense with the idea that the Big Bang possibly did not exist or that it took place much earlier. Conservative science is currently fully committed to reconciling the old worldview with the new discoveries by finding explanations for a kind of turbomatter formation. The Lyman alpha emitters are supposed to help with this. While the James Webb Telescope reveals one cosmic secret after another, in the same breath it shows the experts that they have been on the wrong track for decades. But how do you deal with discoveries that seem impossible at first? With structures that are so unusual that they contradict conventional cosmology? Currently, there is often talk that Webb has overturned everything we thought we knew about the universe and the Big Bang. But the bottom line is that the truth is much more nuanced, and therefore, much more exciting. Max Planck once said, "If you change the way you look at things, the things you look at change." Whether the German physicist already had a view of things in mind at the time that was specifically designed for infrared astronomy is, however, uncertain. What is certain, however, is that the James Webb Telescope has fundamentally changed our view of the universe. In theory, the $10 billion device could detect the heat of a bumblebee on the surface of the moon from Earth. In practice, Webb has already identified a number of mysterious structures in the vastness of space that simply don't fit with our time-honored cosmological models. But how do you deal with discoveries that simply don't make sense on paper? with discoveries that have the potential to shake the entire cosmology to its foundations. Well, these are questions that the experts inevitably had to ask themselves last year. After Webb's near-infrared camera, NIRCam, took a close look at a section of the sky near the Big Dipper, experts discovered 6 reddish points of light in the images, which turned out to be a mystery. Based on the redshift, the scientists from Swinburne University of Technology in Melbourne determined that the light took more than 13 billion years before it reached our field of vision on Earth. It therefore originated from objects that existed 500 to 700 million years after the Big Bang. Furthermore, the characteristics of the points of light suggested the urgent conclusion that these were early galaxies, namely, galaxies that should not exist in this form at all. In principle, researchers would have expected only tiny baby galaxies in this early period of the cosmos. No wonder, after all, according to our current knowledge, there was not enough normal matter back then to form galaxies the size of our Milky Way today. At least that's the theory, but reality should paint a somewhat different picture. In fact, all 6 early galaxies contain more than 10 billion solar masses of stars. One of them could even have a stellar mass of more than 100 billion solar masses. To explain the presence of such massive structures at this early time, either the matter density in the young universe must have been 2 to 5 times greater than the cosmological models predict, or the galaxies must have been born in a way that is completely unknown to us. In view of this, the researchers unsurprisingly described the discovery as a real problem for science. And in fact, this problem should only be further deepened in the context of another discovery. Has Webb blown up cosmology? After the astronomers had tracked down the astonishingly massive galaxies, they initially thought they had made a mistake. However, this suspicion was not confirmed in the course of subsequent analyses. On the contrary, the galaxy, which was added to the star maps a few weeks ago, underlines the fact that researchers should be prepared for further impossible discoveries in the future. Christened with the scientific name JADES-GS-Z14-0, this group of stars existed 290 million years after the birth of the cosmos. In the end, however, the structure not only became the oldest known galaxy ever, but also another mystery. For although the galaxy already existed at a time when, according to our understanding, the first stars had only just been formed, it's already incomparably luminous. The scientists' analyses have shown that the galactic object of desire already comprised several 100 million solar masses of stars. This raises the question of how this was even possible. How could such a massive galaxy form in just 290 million years? In fact, the researchers assume that the collection of stars took around 100 million years to grow to its observed dimensions, and the emission lines of oxygen detected in the spectrum indicate that several very massive generations of stars had already gone through their life cycle before astronomers observed this galaxy. But what do these puzzling discoveries mean for the big picture? Or, to put it another way, if we have already been wrong about the structure formation processes in the universe, could we not also have been wrong about the formation of the cosmos itself? Basically, the scientific consensus is that the universe was born in the Big Bang. In other words, around 13.8 billion years ago, space, time, and matter emerged from an original singularity. Over time, the Big Bang theory has withstood a series of observational tests, and it's also capable of explaining a large number of cosmological characteristics. These include, in particular, the redshift of light from distant galaxies, the presence of cosmic microwave background radiation, the abundance of light elements, and the evolution of galaxies and larger structures. And although the Big Bang theory cannot say with absolute certainty which galaxies will develop where, it can indicate probabilities. With this in mind, experts can roughly estimate how many small, medium, and large galaxies should appear in a given volume at a given time in the universe. Until the launch of the James Webb Telescope, however, we had no direct observational access to the earliest stages of galactic evolution. But now we are smarter, and the galaxies discovered by Webb seem to make a mockery of our understanding of the Big Bang and galaxy evolution in the early universe. Advocates of the Big Bang Theory emphasize, however, that the matter is by no means as clear-cut as it seems at first glance. According to them, the headlines proclaiming the end of the Big Bang ignore a crucial detail. Astronomers estimate the redshift, which gives the distance and, therefore, the age of galaxies, using a technique called photometry, which is incredibly uncertain. So before conventional cosmology is completely broken, more precise measurements of redshifts and the age derived from them would be needed. Farewell to the Big Bang? And so it is that many a Webb discovery has subsequently turned out to be much less spectacular. For example, there are the unusually massive galaxies detected in 2022, which, with a redshift of over 16, are thought to have existed 200 to 250 million years after the Big Bang. A few months and a series of more precise measurements later, however, the record-breaking structures turned into completely normal galaxies. In detail, the redshift of one structure was corrected downwards to 4.9, which means nothing other than that the galaxy age increased from 240 million years to well over a billion years. This is therefore more than enough time to explain their size and shape using the standard Big Bang theory. But what about the other discoveries? Did the new galactic record holder JADES-GS-Z14-0 actually also form significantly later than the first datasets suggest? Well, not really, because the corresponding redshift of 14.32 should actually be confirmed this time. Does this mean that the Big Bang theory has had its day after all? Well, that depends first and foremost on which expert you ask. In principle, some researchers are of the opinion that the Big Bang was actually a big bounce. According to this model, the universe is subject to an eternal cycle of decline and birth, although some experts also have their problems with the name of the one universe. According to them, it's conceivable that the majority of the cosmos has been eternally expanding in an inflationary manner since its birth. This process would only come to a standstill within bubble-shaped sub-areas in which a multitude of sub-universes form. Each cosmic world could contain completely different values of the natural constants, and thus also different physical laws. However, if Nikodem Poplawski has his way, we are all inside a black hole. The researcher from the University of New Haven is convinced that a kind of primordial seed once ripened in the heart of one of these mass monsters, which ultimately burst open and paved the way for the unfolding of our cosmos. Conversely, black holes would therefore embody natural gates that connect two universes, with the restriction that the cosmic gate can only be passed through from one side. The bottom line is that the majority of astronomers continue to adhere to the established ideas. It's quite possible that the existence of galaxies, such as JADES-GS-Z14-0, can be explained within the framework of the Big Bang theory without having to make far-reaching changes. For example, large black holes could have formed before these galaxies and triggered bright bursts of star formation with their incomparable gravitational force. Alternatively, supernova feedback and other mechanisms are suspected to have fueled the unexpectedly high star production of early galaxies. But regardless of whether it was the Big Bang, the Big Bounce, or the multiverse, ultimately, none of these models are able to answer the questions of before and why. In other words, what caused something to emerge from nothing 13.8 billion years ago? Was there a trigger, or was it mere coincidence? And what happened before that? Stephen Hawking once said that time itself only began with the Big Bang, which is why dealing with the before makes no sense at all. Consequently, the Big Bang embodies an event that could not have been caused by anything or anyone. The laws of nature themselves would show us that the cosmos could have come into being without the need for energy or a cause. But other experts question precisely this. And who knows? Perhaps the key to knowledge is just one new James Webb discovery away. Bigger, the Sun. In our everyday perception, our mother star often embodies the cosmic measure of all things, which no other celestial body can match. And in relation to our home system, this is absolutely true. With a diameter of no less than 1.4 million kilometers, the Sun easily outshines all its planetary companions. In theory, The Earth would fit into the Sun more than 1.3 million times. In practice, however, our central star begins to shrink further and further when we compare it with other galactic giants. Located in the constellation Orion, Betelgeuse trumps our fixed star in every conceivable astronomical respect. In detail, the giant star, which is internationally known as Betelgeuse, has a diameter 800 times that of the Sun. In this constellation, the Sun is transformed into a tiny pinhead that would fit 500,000 times in the shoulder star of Orion. The differences in luminosity are no less extreme. Betelgeuse shines 10,000 times brighter than our source of heat and life. As a result, it's even possible to see the celestial body, which is around 650 light-years away from Earth, in the night sky with the naked eye. If you are in the northern hemisphere during the winter, it is practically impossible to miss the red supergiant, and not just since yesterday. In fact, Betelgeuse was already mentioned 2,000 years ago as a yellow-orange glowing dot in the firmament. But like all other objects in the universe, Betelgeuse is not a fixed, unchanging object. Quite the opposite. The determination of its radius using interferometry revealed that it fluctuates by around 15%. Interesting to know, Betelgeuse's radius was the first to be determined using this measurement method. The bottom line is that the fluctuations are by no means limited to the radius. They also affect the brightness. Accordingly, a visible change in luminosity occurs every 2,070 days, a phenomenon that is in turn due to the late stage of development in which Betelgeuse now finds itself. In principle, red supergiants have the characteristic of expanding and contracting again, whereby this pulsation is directly linked to the fluctuations in brightness. However, a few years ago, experts were made acutely aware of just how drastic and, above all, how puzzling this spectacle can be sometimes. An inexplicable interplay. Back then, in October 2019, a process began that ultimately led to an extreme reduction in luminosity. In February 2020, this was no longer even 40% of its average initial value. Since the beginning of astronomical studies, Betelgeuse had never shone so faintly. After experts became aware of this mysterious event, they immediately tried to decipher the reasons behind it. Some researchers saw the loss of luminosity as nothing more than the result of several overlapping brightness cycles. Other experts, however, feared that the incident was the result of something far more dramatic, an imminent supernova. In principle, the approaching stellar explosion announces itself by the celestial body expanding greatly and experiencing a significant decrease in brightness in the same breath. However, as no star has yet been observed directly before a supernova, we do not know whether such a dimming occurs several years or just a few hours before the actual event. However, there is no doubt that Betelgeuse will one day make an explosive exit. According to our current state of knowledge, however, the red supergiant will only bid farewell to the cosmic stage in the distant future. As it only reached its final stage comparatively recently, the final supernova is likely to be a good 1.5 million years away. However, other researchers have set a much tighter time frame and estimate that Betelgeuse will disappear from the space maps within the next 100,000 years. After Betelgeuse literally shone again in its former glory in April 2020, scientists were able to uncover the cause of the drastic drop in brightness in August of the same year. Observations from the Hubble Space Telescope revealed that the star had ejected a gigantic cloud of hot, dense material. This then cooled down, condensed into dust, and shielded the emitted starlight. Due to the cosmic dust veil, it appeared from our terrestrial point of view as if the celestial body had dramatically lost its luminosity. Now that an explanation for the past development had finally been found, it did not take long for the star to come up with another mystery. Since 2023, Betelgeuse has been shining much brighter than usual. What happens when Betelgeuse explodes? Regardless of whether Betelgeuse will explode soon or many thousands of years from now, one thing is certain. As soon as the red supergiant transforms into a supernova, we will once again be impressively reminded of the elemental forces at work in the universe. As mentioned, Betelgeuse already shines 10,000 times brighter than the Sun, but the researchers are expecting a 16,000-fold increase in luminosity for its explosive stellar death. While some experts assume that the brightness of the star will then be comparable to that of the crescent moon at night, others believe that it will correspond to the luminosity of the full moon. In any case, the supernova would be impossible to miss from Earth. But what will the brute spectacle mean for our blue home planet? Will the Earth possibly be wiped out along with its inhabitants? Well, fortunately, it's not quite that dramatic. Basically, the concern with such constellations is that the gamma-ray explosion that will accompany the supernova will also affect the Earth. In the case of Betelgeuse, however, the experts are giving the all-clear. As the star's axis of rotation does not point in the direction of our terrestrial home, the gamma-ray burst will not be intense enough to have a negative impact on our planet. What is particularly exciting, however, is the fact that there may even be two flashes. After the explosion of the star's core, the ejected material could collide with the static shell that surrounds the red supergiant at some distance. And this subsequent collision would also manifest itself in the form of an explosion that would be visible from our blue home planet. But what will be left at the end of this thunderous spectacle? Will the former viewpoint of Betelgeuse henceforth be adorned by a yawning void? Well, most probably not. As is typical for stars of this size, this supernovae is also likely to result in the birth of a neutron star that is 20 times the mass of the Sun. Is Betelgeuse spinning too fast? The neutron stars in question are known above all for their unparalleled rotational speed. In 2004, researchers even tracked down a representative that rotates 716 times on its own axis within a single second. And although Betelgeuse is still a long way from being an insanely rotating stellar remnant, its rotational behavior is already puzzling astronomers. In detail, the images taken by the radio telescopes of the ALMA Observatory in Chile suggest that Betelgeuse is rotating unusually fast. In fact, the star rotates much faster than it should. With a speed of more than 5 kilometers per second, its rotational speed is about 50 times higher than would be normal for a red supergiant. As a rule, stars actually rotate more slowly the further they expand, and Betelgeuse is the only known star of its kind that is thought to rotate so quickly. But what is it all about? Well, one possible explanation is that Orion's shoulder star has literally swallowed itself up. According to this, it is conceivable that Betelgeuse has incorporated a smaller star during its rearing up. What sounds quite crazy at first is not uncommon in reality, because massive stars are known to regularly interact with their close companions. Theoretically, the stellar digestion could have transferred the angular momentum of the swallowed star to the outer shell of Betelgeuse, thus increasing its rotational speed. However, if we follow the explanations of Jing-Z Ma from the Max Planck Institute for Astrophysics in Garching near Munich, things could actually be quite different. After all, Betelgeuse's surface is teeming with gigantic bubbles of rising and falling plasma, so-called convection currents. And this is precisely the crux of the matter. The scientists have deduced the speed of rotation from the bipolar surface structure of the star. This is because while one half of its visible surface shows a blue shift, the other shows a red shift of several kilometers per second. However, the movement of the convection currents can also cause a red and blue shift in the radio radiation. If one very large convection bubble or a group of several convection bubbles moves towards the observer and the other away from him, this can create a so-called bipolar velocity field. In this way, even a star that is not actually rotating at all can appear to be racing around its own axis at a hellish speed. However, future investigations will have to show to what extent this theory corresponds to reality. Brown dwarfs are very unusual objects in the cosmos. They are also known as failed stars because they have some of the properties of a star but do not have the necessary mass to start the nuclear fusion of hydrogen into helium. However, this would be necessary to produce light and heat. Brown dwarfs are formed by the collapse of gas and dust clouds, similar to real or luminous stars. except that they do not begin to glow like conventional suns after the process. Brown dwarfs have many physical properties that they share with other stars. They have a spherical shape and also a hot surface when they form. The mass of a brown dwarf is typically between about 13 and 80 Jupiter masses. This mass is not sufficient to generate the pressure and temperature in the core required to start hydrogen fusion. However, during their early stages of development, brown dwarfs can fuse deuterium. This is a heavy hydrogen isotope that can also fuse at lower temperatures. However, deuterium supplies are sparse, and so this fusion process only lasts a very short time. Stars that can ignite a complete hydrogen fusion enter the so-called main sequence phase, in which they shine stably for billions of years. Brown dwarfs do not reach this phase. Without the continuous energy source of hydrogen fusion, brown dwarfs cool down over time and become dimmer and dimmer. Nevertheless, they produce a mysterious glow, and the James Webb Telescope has now been able to track this down. The Webb telescope detects light in a completely different bandwidth than the Hubble telescope does, or other comparable observatories. Webb captures infrared signals and analyzes these waves with 4 special spectrometers. Brown dwarfs revealed their mysterious glow in the infrared range. On the trail of the strange glow. Brown dwarfs used to occupy an intermediate position in the universe. Researchers saw them somewhere between the largest gas planets and the smallest stars. Scientists mainly attributed this to their size and gravity. However, brown dwarfs may be a category of celestial object in their own right that we have so far failed to recognize. The James Webb Space Telescope has discovered an aurora around a brown dwarf that is over 40 light-years away from Earth. This discovery, called W1935, is special not only because this brown dwarf is luminous, but also because it is close to other stars. Normally, brown dwarfs appear in isolation. At first, it was thought that W1935 might be reflecting light from the surrounding stars, but then the JWST discovered methane emissions on W1935. The methane could produce the aurora. The emissions would also be characteristic of the heating of the atmosphere by charged particles traveling along magnetic field lines and colliding with atmospheric particles. The energy presumably comes from the interior of the brown dwarf. Another theory is that interstellar plasma collides with W1935 and triggers the aurora. Interstellar plasma contains far fewer particles than the plasma emitted by stars, and yet the particle density could be sufficient to explain the mysterious glow around the brown dwarf W1935. The plasma density in free space is probably not the same everywhere either. It could be higher in the vicinity of many neighboring stars. If the brown dwarf passes through a region of space with a high plasma density, this could lead to a glow in the infrared spectrum. There is also speculation that the brown dwarf may not be alone. It could be receiving particles from a nearby active moon or another celestial body. It's possible that we have not yet discovered this object, but with the JWST, we have a good chance of unraveling the mystery. A small moon would probably be too small to be detected by the fine spectrometers, but if it is another object, about the size of a planet, Webb could theoretically detect it. Brown dwarfs are not uncommon in space. In fact, they are quite common and make up a large proportion of the smaller stellar population. At first glance, they seem pointless to us, which is how researchers came up with the nickname hindered star. However, we may have overlooked the fact that this type of star shines in a different class of light and may belong to a world of dark objects that we were unable to see and study before the Webb era. Is there a dark universe? While we know the bright, light-filled universe quite well, the dark universe is still a largely unexplored area. Darkness, dark matter, and dark energy, as well as interstellar space, make up a large part of the entire cosmos. It's precisely here that we could also find answers to all the phenomena and circumstances that we have not yet found in the world of visible phenomena. For example, we don't even know exactly how matter was created, and we don't know the dynamics that contributed to the creation and development of the universe. This is precisely why researchers came up with the existence of dark matter and dark energy. Although we can neither see nor measure them, we can see their effects. Dark matter is a basic building block of the matrix of our universe, and dark energy is a kind of fuel. But in addition to these two, there are other dark objects, such as brown stars and black holes. These phenomena, and the fact that nothing happens by chance in the universe, have led researchers to the idea of a cosmos that exists right before our eyes, parallel to our world, the dark world. We live in it, and it lives with us, or even co-creates our visible structures. With black holes, we only know that they are there because they exert force, and so we can at least explore them a little. We now know that brown dwarfs emit light, but not in the spectrum that is normally visible to us. Our technical capabilities are improving, and we may soon be able to understand this dark universe. Some researchers even say that we need to understand this mysterious dark dimension in order to better explain our own visible world. From the dark universe to the parallel universe? You may be surprised to hear that there is not only a dark world within our own, but very likely one or more other dimensions and worlds hidden in the darkness. In particle physics, this means that there are gigantic empty spaces between the tiny elementary particles. This is also how researchers came up with the idea that matter is not as solid or material as we have long thought. In fact, matter is more nothing than something. In the particle accelerator in Geneva, researchers conducted a series of experiments in the subatomic range and found smaller particles that behave increasingly strangely instead of solid matter components. Just 100 years ago, an atom was tiny. Today, we know that atoms are by no means the smallest particles. They are made up of many other small building blocks: electrons, neutrons, protons, quanta, quarks, and bosons are just some of these particles. To discover the true purpose of our universe and its blueprint, researchers are looking for clues in the subatomic world. A logical way to unravel the mysteries of the material world is to disassemble matter. But that didn't work quite as well as researchers thought. They reached a threshold where particles become so crazy that they defy measurement according to our old physical rules. The German physicist Werner Heisenberg saw this threshold less than 100 years ago, and the threshold was named Heisenberg's uncertainty after him. Quantum physicists now assume that beyond the threshold, in the world of predominant emptiness and darkness, we are far from having reached the primordial ground of the matrix. Rather, it looks as if the magic point of Heisenberg uncertainty is a transition into an infinite number of previous unknown dimensions. Now imagine this. Whether a brown dwarf, a brightly shining sun, a flower, or your bodies, all are made of matter, and within this matter, there is always the Heisenberg threshold, the darkness, and there is the transition into other possible dimensions. This would mean no less than that thresholds to other dimensions exist even within you. This quickly makes it clear how little we have really understood about our cosmos and matter. We probably also know very little about ourselves, our lives, and our possibilities. When we observe and analyze brown stars with our super telescopes like James Webb, we are still only scratching the surface despite our highly advanced technology. What stars and our universe really are in their multidimensionality and in the overall cosmic spectacle, we will perhaps understand at some point when we have new technologies or our consciousness has expanded significantly. Phenomena such as brown stars shining in the red light spectrum may have even more secrets, and their existence as apparently blocked stars could have a deeper meaning that we have not yet understood. It's quite conceivable that these only faintly reddish glowing dwarfs are real and brightly shining suns in another dimension. Other worlds could need this light just as much as we benefit from the light of the sun and base our entire lives on it. What do the lights of the cold stars have to do with quanta? Let's look at the dark stars at the quantum level. Quanta are particles of light, carriers of information, and they are essential building blocks of reality. All quanta have a form of energy that they generate or emit. Basically, they are also pure light, but this light is so tiny and small that we cannot see it with our human eyes. No one has ever seen a quantum with their own eyes. Even atoms are actually invisible. We only know that these particles exist because we have detected them experimentally and can study their behavior and effects. Nevertheless, this means that all matter is actually made of pale light. Even brown dwarfs and apparently dark stars are therefore light objects. In the other dimensions near or beyond the blur, bright light worlds could exist that are identical to mythical worlds, divine dimensions, or simply other universes. This finding is consistent with string theory, which states that there are at least 8 other dimensions to our 4, and that these dimensions are all around us, only we don't see them. Subscribe to the channel now to see even more exciting videos.